Namaste everyone, welcome back to CodeCraft with Poonam. I'm your coding mentor Poonam Agrawal. In our last session, that is session 4, we built our first relationship, right? That is category with many recipe objects. So at the end of that video, we noticed something interesting in the console, right? That is when we loaded a category, we saw two separate SQL queries, right? So that is first query is from our category table, right? And the second query is from our recipe table. So that second query did not fire immediately when we loaded the category. Okay. So it fired only when we called category.getRecipes method. Okay. So today we go deep into what lazy and eager loading are, why the difference matters enormously for performance, and how to choose the right one. Okay, so we will also look at the most common Hibernate bug beginners face, that is lazy initialization exception. Okay, so understand exactly why it happens and learn 3 ways to fix it. Okay. So, for your better understanding, imagine you walk into a restaurant and sit down. Okay, so now we have two cases, that is eager loading and lazy loading, right? So, coming to eager loading, so this is nothing but the our over enthusiastic waiter. Okay, so here the waiter immediately brings you the menu, a glass of water, and all the side dishes, right? And the dessert menu before you have even said a word. So you only asked for the menu, right? But everything arrived at once. So most of it you will not touch. That is pure waste, right? Now coming to another scenario, that is lazy loading. So here this lazy loading is nothing but the attentive waiter. Okay. So the waiter brings you only the menu first. So when you are ready to order drinks, you ask, right? He brings the drinks. When you ask for the main course, he brings it. Nothing comes until you actually ask for it. Okay. So due to this, what happens? Much less waste. Okay. That is only what you need when you need it. Okay. So similarly in Hibernate, lazy loading. So here lazy is nothing but the, it loads the related data only when your code actually access it. Okay. And coming to eager loading, it loads the related data immediately when the parent is loaded. Okay. So in this session, what you're going to learn is what lazy and eager loading mean in Hibernate, the default fetch types, okay, that is at the rate one to many, many to one, okay, and what lazy initialization exception is, okay, this is the most common Hibernate bug, okay, and also you are going to learn exactly when and why it happens, that is this exception, and there are 3 ways to fix it and what is n+1 problem and how to reproduce it to live and how this joint fetch solves this n+1 problem in one line, okay, and when to use this lazy versus eager, okay. So now let's get started. So now coming to here Hibernate fetch strategy defaults. Okay, so by default we have 4 annotations, that is at the rate 1 to 1, at the rate 1 to many, at the rate many to 1, and at the rate many to many. Okay. So here we see the many side relationships and one side relationships. Okay. So here in many side relationships, it includes at the rate one to many and many to many annotations. Okay. So this which may involve thousands of records. Whereas coming to one side relationships, it includes at the rate many to one and one to one annotation. Okay. So here it involves only one related object. Okay. So here this many side relationships, okay, that is here this two annotation at the rate one to many and at the rate many to many, okay, it is a lazy loading. So what it means, Hibernate waits to load data until explicitly requested to avoid performance waste, okay, whereas coming to this one side relationships, it is a eager loading, so which includes at the rate many to one and at the rate one to one. So what here eager means? It means that Hibernate loads the related object immediately because it is cheap to retrieve. Okay. So here when you have a at the rate one to many, that is we have one category, okay, and many recipes, right? For the corresponding category, we have many recipes. So loading all the recipes every time you load a category would be a wasteful, right? So here Hibernate waits. It loads recipes only when you ask. Okay. And when you have at the rate many to one, that means here we have one category per recipe. Okay. So here the category is just one row. Loading it immediately cost almost nothing. Got it? So the memory trick to remember here is that many relationships are lazy by defaults. Okay. And one relationships are eager by default. Okay. So now coming to lazy loading process in Hibernate. Okay. So here how this actually works. So when you mark a relationship as lazy or leave the default. Okay. So here Hibernate does not load the related data from the database immediately. Instead, Hibernate gives you a proxy object. So proxy object is nothing but a fake placeholder. Okay. So for your better understanding, think this proxy as a when you go to a restaurant, okay, so you get the menu, right? There is a page that says desserts. So you ask your waiter, right? That page is the proxy. Okay, the desserts are not listed yet. Only when you say, show me the desserts, does the waiter bring the full list. Okay. So the process for lazy loading is first mark relationship as lazy, okay, and then retrieve parent object. After that, it will access the related data, and then based on that, Hibernate fires query, and then the proxy is replaced with your real data. Okay, so here what it means. So mark relationship as lazy. It means that the relationship is configured to load data lazily. Okay, and then retrieve parent object. So here the parent object is retrieved from the database and then it accesses the related data. So here the related data is accessed through the proxy object. Okay, and based on that Hibernate fires query. Okay, so here Hibernate executes a query to load the related data and then proxy is replaced with real data. So that is the actual data you will get. Okay. So now coming to lazy initialization exception. This is the most common Hibernate bug. Yes. So this is the error you will see most often as Hibernate developer. Okay. So let's see its sequence. Okay. So for that, first open this session and then retrieve the category. Okay. And then close this session. After closing this session, if you try to access any recipes, then this lazy initialization exception is thrown. Okay. So here why it happens is because the proxy needs a live session to fetch the data from the database. Okay, so once the session is closed, the proxy has no way to execute a SQL query. So when you try to access the data, Hibernate panics. It cannot load it. Okay, that's why you get this exception. So now coming to fixing lazy initialization exception. So how we are going to fix it? So to fix this lazy initialization exception, there are three ways. Okay, that is number one, access lazy load before closing this session. Okay, and then number two, that is use join fetch in JPQL. Okay, and then there is another method, that is third method, that is change to eager loading. Okay, so now coming to our first method, okay, that is access lazy data before closing this session. So this is the simplest fix. Okay, so you can access the lazy collection while the session is still open. Okay, so here this is our first method. Okay, first open this session, establish a Hibernate session. Okay, and then return category. So it fetches a category object from the database. Okay, and then access lazy data. That is, it triggers the data loading by accessing the collection, and then close this session. So here Hibernate session is closed safely. Okay, so that here the data is saved in the memory. Okay, and when you uh, try to fix using second method, that is use join fetch in JPQL, then what happens? It loads everything you need in a single query. So here there is no lazy loading needed. Okay. So as here everything is in one query, right? So no proxy is needed. So no lazy loading issue will be there. So this is the recommended approach for most real world use cases. Okay. And next coming to third method, that is change to eager loading. So here what happens is it forces Hibernate to always load related data immediately. Okay. So every time a category is loaded, all its recipes are loaded too. And then this is our another method, that is using join fetch in JPQL. So here for that what you need to do, first open the Hibernate session. So here it establishes the connection to the database. Okay. And then you need to create a JPQL query. So here construct a query to retrieve category and recipes. Okay. And then use join fetch to load recipes along with the category in a single query, and then execute query. Okay, so you need to run the JPQL query to fetch the data and then retrieve single result. Okay, what it will do, it will get the category object from the query results, and then you need to close the Hibernate session. So what it does is it will terminate the database connection, and then when you try to access the recipes, it safely accesses the loaded recipes from the category. Okay. So now coming to which Hibernate fetch strategy should you implement, whether eager loading or lazy loading. Okay. So when it comes to data retrieval timing, okay, in eager loading, it forces Hibernate to always load related data immediately upon parent retrieval. Okay. So here this is initialized immediately. Okay. Whereas coming to lazy loading for data retrieval, here it defers loading of related data until the application explicitly accesses the collection. So here the initialization happens on demand. Okay. And then coming to performance impact. So for the eager loading, risk slow queries and huge joins when multiple relationships are defined or data sets are large. So here the potential performance is bottleneck. Okay. Whereas the performance impact for this lazy loading is it prevents unnecessary data retrieval, keeping initial queries lightweight and efficient. So here it is an optimized resource usage. Okay. And then coming to idle use case, for this eager loading, it best suited for small fixed data sets that are guaranteed to be required every time. Okay, so use it only when you need small mandatory data sets. Okay, and the ideal use case for this lazy loading is it is preferred for large collections or scenarios where related data is not always needed. Okay, use only when you need large or optional data sets. Okay. So now coming to which database fetching strategy should you implement? Okay. So for the n plus 1 problem, okay, we are going to use join fetch as a solution. Okay. So here the n plus 1 problem is when loading n parent records triggers n additional queries. Okay, that is to load the children. So, for example, if there are three categories, right, then what will happen is you will have one plus this three. So, totally, you will have a four queries. Okay. So, for example, if you have 100 categories, then what happens is 1 plus 100, that is 101. 101 queries will be there. Okay. Then what will happen is your app slows to a crawl. Okay, that's why to fix it we use join fetch. So here, let's see query execution pattern. Okay, what happens? It triggers an additional queries for child records. So it causes linear growth in database round trips. Okay, so that's why if you use join fetch, then what will happen? It executes a single query for all the data. So here it maintains the constant performance regardless of volume. Okay. And then coming to application performance, the problem with n plus 1 is it causes the application to slow to a crawl. Okay, so it degrades responsiveness as the record counts increases. Okay, and if you use this join fetch, then what happens? And it ensures the consistent speed regardless of category count. So it provides stable and predictable execution times. Okay. So now coming to lazy versus eager loading. Okay. So default is for the lazy loading, it is a default. Okay. Whereas eager loading is not default. Okay. So if you want to change to eager loading, then you need to set it to eager loading. Okay. And then coming to use case, for the lazy loading, we have at the rate one to many, at the rate many to many. Okay. And eager loading is at the rate many to one and at the rate one to one. Okay. And coming to data loading, here for the lazy loading, you need to explicit with joint fetch. Okay. And eager loading is always ready, right? It always loads the data. And then coming to performance, lazy loading is good. Okay. Eager loading can be poor. Okay. And then exception. So if you try to access data after the session is closed, then here what will happen? It will throw the lazy initialization exception, whereas in eager loading, it does not throw this exception. Okay. So in practice, we keep at the rate one to many as lazy. That is our default. Okay. Use join fetch in your JPQL query when you know you need the children. Okay. And you never switch at the rate one to many to eager just to fix a lazy initialization exception. Okay. Why? Because that just hides the problem and causes performance issues. Okay. So coming to fetch type decision flowchart. Okay. So when you always need related data, so you need to think that do you always need the related data when you load the parent? Okay. So if yes, then you need to think whether is data is small and bounded. Okay, that is the related data small and bounded? Okay. If it's that small and bounded, then eager is okay. Right? That is eager fetching is appropriate for small and bounded data. Okay. If no, then go with this lazy. Okay, stay lazy because there is no too much data. Okay, so in the first case only you need to understand okay what you want. So always if you don't always need any related data, then it's better approach to use this lazy. Use lazy default for at the rate one to many and add join fetch in jpql when needed. Okay, so now coming to lazy initialization exception in Spring Boot. So why this matters for most of the Spring Boot developers is because this lazy initialization exception is the most common error in Spring Boot apps that uses JPA. Okay, so now you know exactly why it happens. Why? Because in Spring Boot, when you use at the transactional, okay, it keeps this session open for the duration of a method. Okay, that is inside at the transactional lazy collections load find. Okay, and outside the at the transactional accessing lazy data will throw lazy initialization exception. Okay, and when you use at the rate query with join fetch, that is the Spring Boot equivalent of what we do today. Okay, so now let's see all this in our example. So in this session, I have made few changes. Okay, so coming to our main.java. Okay, so here this is our main class, main method. Okay, this is our fields. Okay, main course, breakfast, snacks, ID, first recipe ID. Okay, all these are static. Okay, and here we are going to see lazy versus eager loading. So here first method we have seed data. Okay, so here what we are doing is we seed these same three categories with our veg recipes before each demo. Okay, so here go to the seed data. Here this is our method. Okay, private static void seed data. So here you see that here we have opened this session and here we are beginning the transaction. So here we have same categories, that is main course, breakfast and snacks here. Okay, with the description here. And in the main course we have all these recipes, and in breakfast we have all these recipes, and for the snacks we have all these recipes, and then we are persisting. Okay, and then we are committing. After that we are getting the ID. Okay, for the main course ID, breakfast ID, snacks ID, first recipe ID. Okay, and then we are closing this session, and this is our print statement. Okay, So coming to our demo one, here it is. So here, right, this is about seed data. Okay, and then here we have total 6 demos. That is, we have lazy loading in action method, and then here lazy initialization exception method, and how to fix it using first method, that is access inside session, and another method to fix it is to use join fetch method, and we are going to see n+1 problem, and then we are going to see eager loading. Okay. So now coming to our first demo, okay, lazy loading in action. So here, for that first we need to open the session, and then here this is our first step, that is category is equal to session dot find. Okay, so here we are providing this category dot class. Okay, and then this main course ID. Okay, here you see, here we provided all these fields, right? Okay, and then so here what happens is, so here only category table will be queried. Okay, so here you will be getting category dot get name. Okay, and then the next step is we are calling category dot get recipes. Okay, so here you will here we have list of recipes, right? So is equal to category dot get recipes. Okay, and then the next step, what we are doing is we are counting the recipes. Okay, so by calling this recipes dot size method. Okay, and then the step 4 is we are looping through each recipes. Okay, so we will be getting this name and cook time in minutes, and then we are closing this session. And then coming to our another demo, that is demo 2 for the lazy initialization exception. Okay, so here this is the most important demo of this session. Why? Because every Spring Boot developer hits this error. Okay, so now you will understand it completely. Okay, so here for that we are opening this session, and then here we have category. Okay, so here we are finding, right, session dot find. We have given category dot class, and here we have given main course ID. So here you will be getting the category dot get name of the category, and then here we are closing this session. Okay, so here you see that session is closed. Right now what happens, so to handle the exception, okay, we are using here try catch block. Okay, so in try, here you see that int count is equal to category dot get recipes dot size. Okay, so here this will give the count, and here we have catch block, that is here we are providing this lazy initialization exception. Okay, so here in the console you will get the message. Okay, if it hits the lazy initialization exception. Okay, and then coming to the another demo, that is how to fix when you get this lazy initialization exception. Okay, so for that the first method we are using is access data inside open session. So here first we are opening the session. Here we have category, right? Same thing. When you here we have you will get the name of the category. Okay, so here when you access the recipes while the session is open, okay, so here you have list of the recipes, you will get the recipes, its size. Okay, and all the recipes loaded successfully, its count you will get, and one by one you will get all the names, what are the recipes present, right? And then you're going to close this session here. So and then session is closed, and then what you're doing, you're finding the recipe size. Okay, here recipes dot size. So here, this is the simplest fix. Okay, so it accesses the lazy data while the session is still open. Okay, so here what is happening is we are closing this session, right? So now it is safe to close. Why? Because data is already in our Java memory. Okay, and after that when you try to get the size of a recipe, it still works here. Here no proxy is also needed, right? So here what happens is once get recipes method fires the SQL, okay, and loads the data, the proxy is replaced. So with a real array list in memory, closing this session after that is completely safe, the data is now a plain Java list. That's why no longer a proxy. Okay. So now coming to another demo, that is using second method, that is use join fetch, which is the most recommended method. Okay. So here what happens is when you load everything you need in a single SQL query. Okay, so no lazy loading is needed, no proxy is needed, no session dependency is needed. Okay, so here for that we are opening the session. Okay, and then here we have query, we have created the query. Okay, select C from category, join fetch, C dot recipes, where C dot ID is equal to ID. Okay, category dot class, and here we are setting the parameter as ID, main course ID, and here we are using this get single result method. Okay, and then we are closing this session. After that, we are looping one by one, and we will get the names of the recipe and cook time in minutes. Okay. So here you see that here we have only one query, everything loaded, and session can be closed immediately. Okay. And then coming to our another demo, that is n+1 problem. Here we are opening this session. Okay. Here we have list of categories. Here we have created a query. Okay. So here you see select C from category, C ordered by C dot name ascending order, category dot class, and get result list. And here we are looping one by one. Okay, all the categories. Here you will get the size of the how many recipes you have in this category. Okay. So you will get the name and the recipe count. Okay. And then here we are closing this session. Okay. So next coming to, so here int total A is equal to 1 plus 1 category, 1 plus categories dot size method. Okay. So here what is happening is if we had 1000 categories, okay, then you will get 1001 queries. So that is the n+1 problem here. Okay. So to fix it, we are using this join fetch. Okay. So here, this is our another session. Okay, session B we are opening. So here we have list of categories. So here you see here we have only one query. Okay, that is select distinct C from category, C join fetch, C dot recipes order by C dot name, ascending order, and category dot class dot get result list. So here we have only one query, right? And then here we are closing this session, and then here we are looping this category. Okay, one by one, and you will get here get name and its size, recipe size. Okay. Here you see that there is, so here you see that there is no extra SQL here, right? Data is already in the memory. So here data is already in memory from join fetch. Okay. So now coming to another demo, that is eager loading. Here we are opening this session. Okay, here we have recipe. Okay, recipe is equal to session1 dot find. Here recipe dot class. Okay, here we are using this first recipe ID. Okay, so here we are getting recipe dot get name. So your recipe is loaded. Okay, so you see string cat name, that is category name, is equal to recipe dot get category dot get name. Okay, so here you will get the category name, and here we are closing this session. Okay, so now we will run this. So here this is our seed data, right? Here we are persisting. So here we are persisting all the categories, right? This one. Okay, and then we are getting the IDs for this main course, breakfast, snacks. Okay, and then here we are printing the statement, right? So here you see that Hibernate generated a category table first, and then it created recipe table. Okay, after that here Hibernate this generated insert into statements for the category. Okay, here you see with its values. Okay, and then after that Hibernate generated insert into statements for the recipe table as well. Okay, and then here you see that seeded three categories. We are persisting three categories, right? Seeded three categories, and here you got 9 Indian recipes. In that we have total 9 recipes. Okay, and then here we got the category IDs, right? Here you see this one. Okay, so here we have the category IDs, that is main course is 1, breakfast is 2, and for the snacks ID is 3. Okay, and then coming to another method. Okay, so here we have this one, lazy loading. Okay, so now, so here for the lazy loading, okay, here we have all the steps, right? So you see here, this is our first step, calling session dot find. Okay, here this is our category dot class comma ID. Okay, so here you see what is happening in the first step is when you're querying this session dot find. So here it loads only the category. Okay. And then what happens is query 2 fires at recipes.size method. Okay. So here it will load the recipes when first accessed. Okay. And here this get recipe method alone does not fires SQL. It just returns the proxy reference. Okay. That is here proxy reference is free. So the SQL fires when you actually use the data. Okay. So here Hibernate generated the select statement, okay, from the category table, okay. So here you see that find method completed only category table was queried and then it loaded the main course here, okay. So here you see that step 2, this one calling category dot get recipes, okay, and then the step 3 calling recipes dot size, okay. So you will get the count. For that here you see that Hibernate generated the select statements, okay, from the recipe table, okay. Here you see. And it provided the recipe dot size as 4. Okay. So for the step 4, this one, it looped through the recipes one by one. Here you see, you got all this, right? So now coming to another demo, that is lazy initialization. Okay. Here you see. Here we are loading this category, okay, category dot get name, and we are closing this session. After that we are trying to get the size of the recipes. So here you see that what is happening. Here Hibernate generated select statement, okay, from the category table, okay, here. And then here you see that it loaded the category main course, this one, okay, and then session is closed. After that, when you try to get the size, so what is happening is here you see that failed to lazily initialize a collection of role. Here this is what you got. Could not initialize proxy, no session. This message you got it here. Okay. So why it happened? So here why it happened because category dot recipes was a proxy, right? No data loaded yet. Okay. So the proxy needs an open session to run select SQL. So when you have this session.close method, so it destroyed the session, right? So when proxy tried to fire SQL, then no session was available. That's why it got crash. Okay. So this is the exact error. Okay. So this is the exact error appears in Spring Boot when you access a lazy collection that is outside your transactional method. Okay, so the fix is always one of the three things, okay, that which I have showed you. Okay, so now coming to how to fix this error. Okay, so here we are opening the session given this category name, right? So here coming to this Hibernate generated, okay, select statement for this from this category table, okay, and then here we are accessing this category is loaded, okay, main course, and then accessing recipes while session is open. Okay, here we are trying to access the recipes while it's open. Here you see, right? So for that, here it generated the select statement from the recipe table. So here you got all these recipes. Okay, see recipe loaded successfully, get name, you got all the names. Okay, and its size. Okay, so here you see session dot closed and you got this size. Okay, this one. Here why? Because here you already have this recipes dot size within this session. Okay. So now coming to another demo, that is using join fetch method, we are going to fix here. So here you see we have given only one single SQL query. Okay. So here you see executing join fetch query. Okay. So Hibernate generated our select statement from the category table. Okay. And then we are joining. Okay. Here we used join fetch, right? So here you see it joined the recipe table. Okay. And then here you got all this. Okay. Name with cook time in minutes. Okay. Now let's see n+1 problem. Okay. So here Hibernate generated the select statement from the category table and then from recipe table as well. Okay. And here you see that Here we will get the name and count. Okay, so here we have breakfast. In breakfast we have 3 recipes. Okay, and then Hibernate generated another select statements from recipe table. Okay, for the main course here you got 4 recipes, and then similar with the snacks, here you got 2 recipes. Okay, so here you see that we have total 1 plus 3, that is equal to 4 queries for the 3 categories. Okay, so Hibernate generated 4 SQL statements. Okay, so here you see this is the first one. Okay, from category. Okay, this is the second one from recipe. Okay, and this is the third one from recipe, and this is the fourth one from recipe. Understood? Here you see, once again I will show you. So this is the Hibernate generated select statement. Okay, from the category. Okay, this is the one. Okay, and then this is another one, another SQL statement, that is from, this is from recipe. Okay, one from category and n times from the recipes table. Okay, so that is one. This is plus this recipes, second one. Okay, and then this is third one. Okay, and then this is fourth one. Understood? So total we have this one is category and plus this is 3 recipes. Okay, so 1 plus 3 is equal to 4 queries for the 3 categories. Understood? So for that, here we have another scenario, that is the session B here. Okay, so here you see we are giving single query. Okay, join fetch. Okay, so here you see that here we didn't use, for the session A join fetch we have not used, right? So here in session B here we are using join fetch. Okay, so now see what happens. So here Hibernate generated this select statement from the category table and joining the recipe. Okay, so here you see you got breakfast 3 recipes, main course 4 recipes, snacks 2 recipes, right? So here you can see only one SQL query got generated here, right? And you got all the details. That's why. Understood the difference? Hmm? So this is why join fetch exists. So in a production app with hundreds of records, this difference is the line between a fast app and a broken one. Got it? And then coming to this one, eager loading. Okay, so here. This is our eager loading. So here Hibernate generated the select statement from the recipe table. Okay, and then here recipe loaded, that is palak paneer. So you got the name. Okay, and then Hibernate generated the select statement from category table, and here you got this category name, that is main course. Okay, so here you see that session factory closed cleanly. Okay, so this is for today's session. If you liked my teaching, then do let me know through comment and hit the like button and share it with your circle so that it will be helpful to them. And do not forget to subscribe and hit the bell icon so that you will not miss any of my videos. Till then, keep learning, keep growing. This is Poonam Agrawal from CodeCraft with Poonam signing off.